Hello! In this chapter, we're gonna talk about signal detection, which is very important part of the receiver. Remember that in the previous chapter, we found out that the optimal receiver filter is mask filter. When we derive the mask filter, it's based on the assumption that the channel is perfect, which means there is no noise, there is no distortion in our communication channel. But now we consider the presence of noise in the communication channel. We focus our attention on the simplest channel model, which is the additive white Gaussian noise channels. We investigate how to perform signal detection for wireless modulation scheme. Since the problem of signal detection involves hypothesis testing, we shall start our discussion there. In hypothesis testing, there are impossible outcomes in the sample space. In digital communication system context, M hypothesis correspond to M possible signal points with the corresponding probability P1 until Pm. For the hypothesis or the outcome, we can define as a random variable, for example, random variable h, equal to a specific value h if hypothesis h occurs. Remember, when we talk about random variable, normally we use the uppercase letter. And when we talk about specific value, we use a lowercase letter, like in this case. The probability of hypothesis is also known as a priori probability because we know it beforehand. And in our signal in the communication system, we have the signal point as a hypothesis. So we also assume that all signal points or hypothesis is equally likely or they have the same probability to be occur. The observation is also random variable. So it can be also random vector if we talk about multiple random variables. So in our context, it's our received signal. And for the communication channels, this is reflected by the probability Fr given H. And normally we assume that they are known because it's a characteristic of our channel. The goal of hypothesis testing is to make the decision based on the observation R, which hypothesis H occurs while maximizing the probability of correct decision, or in the other word, minimizing the probability of error. And the decision we usually use hat on top of the variable. Normally it means decided value or the estimated value. So the goal, we want the probability of correct decision to be maximized. That is probability h hat is equal to h. And the opposite one, the probability of error, is 1 minus the probability of correct decision, PE. Any question, do not hesitate. Don't let them go before it's too late. Now, let's talk about the maximum a posteriori or MAP decision rule. As I mentioned earlier, the goals of signal detection is to maximize the probability of correct decision or the probability of h hat equal to h. The probability of correct decision can be thought as a marginal probability density function, which can be expressed as a conditional probability. Let's consider x equal to h and y equal to r.